Here we are on page 3 of trig functions. Below is a table which shows the mean monthly temperatures for a city in Greece. The x coordinates are given first, the y coordinates are given second as usual. The x coordinates are given in months, but we can translate the months to 1, 2, 3 instead of January, February, March, so that the numbers from 1 through 12. The temperatures given are the y coordinates. Starts with 15, 14, 15, and so on. Not really apparent here, but they say it's cyclical because we can apply a sine function to it. So here is the sine function, the standard sine function. Looks kind of like the one we used in the investigation. We know what A, B, C, D are. I wrote some of the formulas here for A, B, C, D. It says to find good estimates for the constants A, B, C, D. Without using technology. Let's see. To use January equals 1, February equals 2, etc. Okay, so I kind of put them in the order that normally we would do it. First thing we're going to do is we're going to try to find the minimum and maximum y. Those are useful for finding both A and D. Let's see, 15, 14, where is the maximum y? Looks like the biggest y is 27, right? So I'm going to circle that in green. 27 is the largest y, and then I'm going to look now for the smallest y. Maybe it's 14. Okay. And using these two values, 27 and 14, we can calculate both D and A. So D is going to be the minimum value and the maximum value added together. So I'm going to put the 27 down. I'm just going to go ahead and put it there too, so I don't need to change colors later. And the minimum value is 14. 14. Okay, so this would be 14 plus 27 divided by 2. 14 plus 27, that would be 41, I think, divided by 2. So it's D is equal to 20.5. The A value is going to be 27 minus 14 is 13 divided by 2, which is going to be 6.5. And the B value is related to the period. There's two ways you could do the period here. One is you could check the distance between the minimum and maximum and then double it, right? Because the distance between the minimum and maximum is half of a period, right? If it was the whole period, it would start from the far left to the far right. 1, 2, 3, 4, 5. There's 5. There's 5 months between February and July. The other way you could do it is this is a year long, right? This is a year-long cycle. So if it's a year-long cycle, that means the period is 12. If the period is 12, then B is equal to 2 pi over 12. So that would be pi over 6. B is pi over 6. Okay, and last thing we need to calculate is C. C, remember, is the place basically where the function starts. So where does the sine function start? It's kind of hard to see. One thing I'm going to do just to make it easier is I'm going to sketch the function, and this is going to be a really rough sketch. I'm just going to sketch it on top of the numbers here. So since 27 is the peak, then that would kind of be the top of the sine function. Since 14 is the minimum, then it would kind of look like this, right? Oops, this is yeah, kind of like that, okay? So where, if this is, the sine function, where does the sine function start? Remember where the sine function starts. It starts in the middle, but going up. So it would be here or here. Wouldn't be there because that's in the middle going down. So it's going to be in the middle going up. In this yellow curve I drew, it looks like going up would be around, I don't know, here. I mean, in the middle going up would be around there, right? Kind of like that. So I would say it's between April and May, the beginning of this sine curve. So I would say that the C would be between month 4 and month 5. So that would be 4.5. Okay? All right, so if I wanted to write my function out, I would put 6.5 sine b pi over 6 t minus 4.5 plus d, which is 20.5. Now what I'm going to do is I'm going to check my answer with technology by I put all the points into stat edit, just like here, okay? And then in y equals, I'm going to input this function, 6.5 sine pi divided by 6 pi divided by 6, oops, divided by 6 x minus 4.5 close parentheses for sine plus 20.5. Okay, and then I'm going to graph it. And by the way, I already beforehand changed the zoom to zoom stat. Always need to do that. If you need to, you need to do stat plot and turn the dots on. And that looks pretty good, especially for eyeballing everything, right? Okay, it says to use technology to check your answer. That's pretty good. Remember that you might need to turn on your stat plot by going into second stat plot and clicking this to on. Okay, so that worked out pretty well. All right, let's move on to the next one. At the MAASL base in Antarctica, the mean monthly temperatures for the last 30 years are, use a sign model without using technology. So we're going to do pretty much the same thing we did before. So let's just look at our formulas just to review them, D, A, and B. Okay, so D, I'm going to take my minimum value. Let's see, these are negative temperatures. So the most negative number is negative 19, so that'll be the minimum. The maximum will be, looks like around here, because the 0 degrees is the maximum temperature. Okay, so for D, I want to add the y values, which are 0 and negative 19, and then I'm going to divide by 2. So negative 19 divided by 2 is negative 9.5. Okay, what about A values? A values, I'm going to do the maximum value minus the minimum value and divide that by 2. So that'll be 19 divided by 2 is equal to, that'll be positive 9.5. Okay, and then the B value. So the B value could be measured between the distance between the minimum and the max. Looks like it would be between like 1.5 and 8. 1.5 would be halfway between January, February, and 8. That would be, what would that be? 6.5, okay? And then you double that, and that would give you the period, right? Again, we could also say, okay, this is a yearly temperature or a yearly cycle. So it's 12 units would be the width of this cycle. Okay, so the period would be 12 actually in this particular case. We don't really need to use 6.5 doubled, which would give you 13, because we know that the cycle is actually 12 months long. So then we could say 2 pi over p is equal to 2 pi over 12 is equal to pi over 6. Last of all, we'll find the c value. The c value is where this function starts. And so, again, I'm going to make a little sketch. There's the max. There's the min. And it goes back up again. Okay, so where does this sine curve start? Remember this, oops, man, I keep doing the same mistake. Okay, the sine curve, remember, the place where it's in the middle and going up is the beginning of the sine curve. Looks like it's about, I don't know, here? maybe in October. Okay, so I'm going to put my C value as October 10. All right. All right. Number 4. Some of the largest tides in the world are observed in Canada's Bay of Fundy. The difference between high and low tides is 14 meters, and the average time difference between high tides is about 12.4 hours. They don't provide us with a whole bunch of data here. They just give us some characteristics. I'm going to draw a sketch, and then I'm going to try to write the numbers on the sketch. Okay, so the difference between high and low tide is 14 meters. So this distance here is going to be 14 from top to bottom. The average time difference between high tides is about 12.4 hours. Okay. That's all the information they give us. So let's see. Find a sine model. So if we need to find a sine model, what do these numbers tell us? Well, 12.4 is obviously the period, right? So I could find the b value by doing 2 pi over 12.4. If I do that on my calculator, I can see 2 pi divided by 12.4 is 0.506. So my b value is 0.506. What is my a value? My a value I could find from this peak-to-peak distance of 14. Remember that the a value is half of the peak-to-peak distance because it's from the center to the top or the center to the bottom. That means my a value is 7. I don't really know where the starting point of this thing is because they never tell us what the height of the tide is at midnight. So the c value, let's just keep it at 0. And then the d value, remember, is the mean line. Well, they don't really tell us what the tide heights are. So maybe what we could do is we could just set the lowest point to be 0, and then the highest point, of course, would be 14. If the lowest point is 0 and the highest point is 14, we could find the d value by averaging the two. So the mean line height would be 7, so the d value would be 7. So then my sine model would be 7 sine 0.506 t plus 7. Okay? All right, so that's it for page 3. Page 4. The cosine function cosine x, like the sine function sine x, has period 2 pi, amplitude 1, and range -1 to 1. Okay, or we could put that as -1 less than or equal to y is less than or equal to 1. The shapes of the two functions are the same, but cosine is a horizontal translation to the left of sine by the amount of blank radians. So we'll draw sine here. And then the black one, of course, is cosine. How much is cosine shifted to the left? So we know that the high point of sine is 90 degrees. That would be pi over 2. And now the high point of cosine, the peak of cosine, is at 0. So the peak is shifted to the left by pi over 2 radians, 90 degrees. Okay, so cosine x is sine x plus pi over 2. Does that make sense? Positive pi over 2, that would be a shift to the left because it's bizarre world, and that's exactly what we said. Good. Okay. The general cosine function is this. It looks just like the sine function, except it's got cosine written here instead of sine. A is not 0, of course. That would make the thing all smashed. It would just be a horizontal line. That's meaningless. And b is positive. No reason to put negative periods or negative b values. What is the math relationship between b and period? By now you're used to b equals 2 pi over p being an equation that you use a lot. Number 1, given the graph of y equals cosine x, sketch the graphs of the following. So first we're going to do, I'm just going to draw cosine x first, just so that we have a reference, kind of like that. Now I'm going to do 2/3 x, so 2/3 cosine x. So 2/3 cosine x would be like 2/3 as high. So it'd be slightly. So you can see that it is, 2/3 multiplied on the outside is a vertical compression, right? So the blue is vertically compressed relative to the red. Y equals negative cosine x. Let me draw the reference cosine function again. There's the reference cosine. Now I'm going to draw an inverted cosine. Okay, and then now I'm going to draw a wide cosine, because if it's divided by 2 inside the parentheses and it's horizontal, it'd be Zaha world, so divided by 2, instead of making it smaller, makes it bigger. It's going to make it wider. So the original cosine function looks like this. I have enough space here to draw 2 cycles because it's 4 pi. And now I'm going to draw this pink twice as wide one. There we go. Okay. And then finally, let's see. We're going to do cosine cx minus pi over 4. So this would be a horizontal because it's inside parentheses, and plus or minus would be a horizontal translation. It would be left or right. Since it's negative, you would think it would go to the left, but it's Zaha world, so it's going to go to the right. So we're going to shift right by pi over 4. So I'm going to do that here in, let's see, orange. So I'm going to do that up here in orange, and I'm going to take the red function and I'm going to shift it to the right by pi over 4. So everything's going to be shifted to the right half a square. All right. And let's see, now let's do cosine x plus 2. Plus 2 is on the outside, so that would be a vertical translation. Since it's not Zaha world, plus 2 does what you think it might. It would go up by 2. So instead of the reference function, which would just look like this, I am going to make a green function which goes up 2 units. Everything's going to be 2 units up. So it looks like that. And then for the last one, I'm going to do 2 things. I'm going to shift it down by 1 unit, and I'm also going to shift, let's see, plus pi over 4. So you would think that would be the right, but it's Zaha world, so it's to the left. I'm going to shift to the left by pi over 4, and I'm going to shift down by 1. So let's take the red function, and we're going to shift to the left by pi over 4, which is half a square, right? A whole square is pi over 2. Half a square is pi over 4. And then I'm going to go down 1. So I'm going to shift half a square over, and then I'm going to go down. Okay. So shift over half, and then, yeah. Okay, and then now I'm going to draw it. Kind of like that. Okay. So that would be 2 translations, a vertical one and a horizontal one. Okay, number 2, without graphing them, state the periods of y equals cosine 3x and y equals cosine pi over 50 times x. Okay, state the periods. So remember, these are not the periods, although they're related to the periods. They're actually the b values. So let's use the conversion. P equals 2 pi over b, which is kind of the opposite of what we were doing before. Before we did b equals 2 pi over p, but you can rearrange it algebraically, and you'll see that p is also equal to 2 pi over b. And so if b is 3, P is 2 pi over 3. And if B is pi over 50, then P is 2 pi over 50. Now we're going to do the hardest math in 11th grade math, which is the 5th grade math. We're going to divide by pi over 50. Remember, we just invert and multiply. So the pi's cancel out. 2 times 50 is 100. Okay? Period is 100. Find the cosine functions shown in the graph. In this first one here, let me first draw what the parent function would look like. Here's 2 pi, so the parent function would be 2 pi wide. So I drew a cosine that's 2 pi wide. Oh, but I made it too tall because look, the y-axis has -2 and 2 marked. I want to have the, the parent function just -1 to 1. So kind of like that, right? So I can see that the black function is transformed. It looks like it's transformed both horizontally and vertically. Vertically, you can see that instead of going from -1 to 1, it goes from -2 to 2, so the a value appears to be doubled, right? And the width has been adjusted because, like, the black function width has been adjusted because if you look at how many periods there are shown, there's 2 periods. So like 1 period is actually only pi wide, right? 2 periods are 2 pi wide, 1 period is pi wide. So that means our period is pi. And so if we want to find our b value that corresponds to 1 pi wide, we would do b equals 2 pi over p. So it would be 2 pi over pi. So b is equal to 2. So our a value is 2 and the b value is 2. C value is 0 because it's starting at the appropriate starting point for cosine. The d value is 0 because you can see that it's on the mean line is centered at y equals 0. So it's just 2 cosine 2x. Okay. What about this next one? This next one, let's see. There's a couple of ways we could do this, but let's assume that this is like an upside down cosine. So the regular cosine is going to be kind of like this, right? It starts up here, and this one's starting. Oh, I forgot to check the y-axis. Look at this. The y-axis is -5 to 5. So if I drew the parent function, it would look kind of like this, right? About like that size. So there is a vertical stretch going on here. The vertical stretch, not only is there a vertical stretch by about 5, but it also inverts the cosine because instead of starting at the top, it starts on the bottom. So we could put -5 for our a value, and then that takes care of both, okay? Anything else we need to worry about? Well, the width of one period is 6. So what if we said that the period is 6? That would help us find the b value. So instead of instead of b equals 1, it would be 2 pi divided by 6. And if we wanted to figure out what that is, 2 pi is actually very close to 6, right? Let's say it's 6.28, right? 1.05. Okay, so our b value is going to be 1.05. The a value is going to be -5. C value, we took care, another way we could look at this is instead of saying it's an upside down cosine, we could say it's a cosine that's shifted over, right? But we've already taken care of that. We'll talk about that in 1 second. The d value, of course, is just 0 because the mean line is still centered on the y-axis, okay? So let me just tell you, what if instead of thinking of this as an upside down cosine, we thought of it as a shifted cosine, then we would just put a equals +5, right? And the b value would still be 1.05. And then what we need to do is we just need to shift cosine over a certain number of units. Looks like it would be half of 6. So we're shifting it over 3 units. So then we could just say, okay, our c value is 3. And so that's another possible answer. We keep A equals positive 5 instead of negative 5, and then we could say that C equals 3. Okay? I think that's it for this page. Yeah, it is.